uh, these two factors will affect the trends of atomic radii across period and down a group. So look at this periodic table. So I want all of you to focus to the element in the period 2. So we have here is a lithium. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So the proton number of what we call here the lithium is 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon is 10. So for the element that is in the same period, the period is the number of period is same. Means that the shell is number of shell is same. Okay, but all of that element come from different group. The group is different. So the factors that will affect the periodicity for the element across a period is effective nuclear charge or shielding effect.
Effective nuclear charge.
Okay, so the effective nuclear charge, I will use the ZEF here, the symbol of ZEF here. So if you have higher crossing a period, how do you illustrate the value of ZEF? Is it increase or decrease?
Increase.
Increase. Why it is increase?
Number of proton is increased too.
Okay, number of proton is increase crossing a period. So what happen when you have higher value of Z? What happen to the nucleus attraction?
It's stronger.
Okay, it will have stronger nucleus attraction. So the nucleus attraction towards outermost electron is getting higher from left to right. So how about size? When you have stronger nucleus attraction, what happened to your electron? Is it further from the nucleus or nearer to the nucleus?
Nearer.
Nearer to the nucleus. So
Mm-hmm.
can you imagine when your electron is getting nearer to the nucleus, what happened to the size of atom?
Decrease. Decrease.
Decrease. So from left to right in the periodic table, the size of atom will decrease. So for period 2, the bigger atom is lithium and the smallest atom is neon. Okay. How
Yes, madam.
about down a group? Okay. How about down a group? Down a group. What you see here for the element down a group. Okay, you tengok down a group from hydrogen until francium. Okay, what do you see? Here is the group the group is same but the period is different. Means that number of shell. Okay, so the trend of periodicity is depending on which factor? Shielding effect or effective nuclear charge?
Shielding effect.
Okay, shielding effect. So our shielding effect is depends on what factor?
Number of shell.
Okay, number of shell. So how do you illustrate the number of shell for the element of hydrogen until francium?
Increase. By
Increase. So down a group, the number of shell increase means that the shielding effect will
increase.
increase. Therefore, the nucleus attraction towards outermost electron.
Decrease. Decrease.
Okay, decrease. Okay, how about the size? Be
Bigger. Increase.
bigger.
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 It will be getting bigger from hydrogen to francium. Okay, so we go to the second trend, which is electronegativity. So the trends of electronegativity across period and down a group. So what is electronegativity? Electronegativity is is ability of an atom to attract electrons toward itself in a covalent bond. Okay, it reflects the ability of an atom to attract electrons. So this ability is strictly depends on the strength of nucleus attraction. What does it mean? When you have stronger nucleus attraction, is it easy or hard to attract electron?
Easy.
Easy to
Easy
attract.
to attract electron. So it is easy to attract electron. So the ability to attract electron will reflect the electronegativity. So means that your electronegativity is
High.
Hi.
high. Okay, high. How about if you have weaker nucleus attraction? Okay, is it easy to attract electron?
No, hard to
No.
No.
attract.
No
No. So
medium.
hard to attract electron. So the electronegativity
Decrease.
Decrease.
de
Low.
decrease. Okay, it will low. So how about the trends? Okay, we know that across period, because of electronegativity strictly depends on the nucleus attraction. So a crossing period, the nucleus attraction is
Stronger.
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 Okay, across period, nucleus attraction is getting stronger from left to right. And then what happened to the electronegativity? Increase. So it will become like this. How about down a group? The nucleus attraction down a group
Weaker.
Weaker.
weaker. So how about the electronegativity?
Decrease.
Decrease.
De
Decrease.
decrease. So it will become like this. Okay, so we look at the third trends, the first ionization energy. So what is the first ionization energy? The first ionization energy is the minimum energy required to remove an electron from an atom. Okay, to remove electron. Earlier, the electronegativity attract electron towards atom. So for the ionization energy, remove electron from atom. So it depends on the nucleus attraction towards the electron. So it also depends towards the nucleus attraction. Okay, if you have stronger nucleus attraction, is it easy to remove the electrons from the atom?
No.
No. So it
No.
is hard to remove the electron. Did you have less energy or more energy in order to remove the electron?
More energy.
More
More,
energy.
more energy. So energy would be high. If you have the nucleus attraction, so is it easy to remove the electron?
Yeah.
Yeah.
Yes.
Okay, easy to remove electron. So the energy required to remove the electron would be
Low.
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 low. Okay, so when we look at the periodic table, so a closing period, we know that the nucleus attraction is getting stronger or getting weaker from left to right,
Stronger. Stronger.
stronger. So what happened to the ionization energy?
Increase.
Increase from left to right, like this. Okay. How about down the group? Nucleus attraction,
Weaker. And
weaker.
stronger.
Okay, weaker. So the Trend in ionization energy?
Decrease.
decrease,
Decrease. So as a conclusion, the size of atom will decrease or increase across a period.
Decrease.
Decrease.
Decrease. So the size of atom is decrease. This one is size. Okay, how about ionization energy and electronegativity?
Increase.
Increase. Okay, so this one is first ionization energy and the electro. How about down a group? The size of atom is
Bigger.
bigger. Okay, this one is size. How about the ionization energy and electronegativity?
decrease.
Decrease.
Decrease. So it will become like this. So this one is ionization energy and electronegativity. So as a conclusion, when your size is smaller, means that it will have higher
Higher.
ionization energy and higher electronegativity. Okay, the anomalous case in terms of first ionization energy. There are uh, anomalous case here, which is between group 2 element and group 13 element and group 15 and group 16 element. Okay, have you read about the anomalous case?
Yes.
Okay, so between group 2 and group 13 element, we know that, for example, boron and beryllium. Boron will remove the electron from 2p orbital. This one is boron. And then beryllium will lose electron from 2s orbital. So in your notes, what is the statement given by your notes? Which one need more energy to remove the electron?
Beryllium.
Okay, beryllium need more energy to remove from to remove the electron from the 2s orbital because this orbital is completely filled orbital. Okay, this one for boron, the electron is removed from 2p orbital. So this electron is partially filled orbital. So when you compare the stability of these two orbitals, which one is more stable? The 2p orbital of boron or 2s orbital of beryllium?
2s orbital of beryllium.
Okay, 2s orbital of beryllium. This one is more stable. So you need more energy to remove electron from stable orbital. Okay, understand for group 2 and group 13 anomalous case?
Yes,
Understand.
madam.
Okay, how about group 15 and group 16? Okay, for group 15 and group 16, we will use nitrogen and oxygen as an example. So when we look at nitrogen, the electron is removed from 2p orbital, which has which is half filled orbital, and then O is removed from also 2p orbital, but the 2p orbital for oxygen is partially filled. When you compare between half filled and partially filled orbital, which one is more stable?
Half filled.
partially,
Half filled. Okay, half filled orbital is more stable. So you need more energy to remove the electron from stable orbital. Okay, you may refer the stability of this orbital in our notes, chapter 5. Okay. Third objective, we comparing the size of ions and its respective reactive atom. What you see here, cation is always smaller than its atom, means that we are comparing between sodium and sodium ion, means that sodium ion is smaller than sodium atom. That is example. Okay, for an ion is always greater than its atom. For example here, we have chloride ion is greater than chlorine atom. Okay, why? Okay, to become sodium ion, to become cation, your atom will lose electron. So the electron will be removed from the valence shell. So the electron repulsion will decrease. What does it means by electron repulsion? So we know that inside sodium we have 11 electrons. So each electron will repel each other. Kan dia negatively charged kan. So dia akan saling menolak antara satu sama lain. Tapi bila awak dah remove one electron, what happen to the electron repulsion?
Degree.
Decrease.
Decrease.
But the attraction between the electrons and nucleus become getting stronger. Why? Because the nuclear charge is remain same, but the number electron is different now. Okay, when we compare between sodium atom and sodium ion, so for sodium atom, our positively charged proton will attract electrons. But in sodium ion, our positively charged proton will attract only 10 electrons. So when you compare the attractive force, which one is stronger?
11 attract 10.
11 attract 10. So bila nucleus attraction stronger, what happen to the size?
Smaller.
Dia akan jadi smaller. Understand why cation is smaller than atom?
Yeah.
Okay. So how about anion? What happened to the anion? So when electron is added, the mutual repulsion is increased. Okay, what does it mean? So let's say our chlorine atom has 17 17 electron, right? It's already has 17 electron. So we know that electron with electron will repel each other, correct?
Yes, madam.
Yes.
Okay. So if you have electron from the outside enter your atom, what happen here?
The size bigger.
Why the size is bigger? Because the electron inside the atom try to repel the electron that is come from outside. So dia akan cuba menolak elektron ni. So apa jadi dengan elektron cloud dah?
Expand.
Expand. So bila dia expand, maksudnya dia jadi lagi
Besar.
Besar.
besar. Okay, faham?
Faham, madam?
Faham, madam.
Okay. So